Hello everyone, welcome to my Smash Bros. Prototype Devlog. Here I'll explain how the mechanics of my Smash Prototype work. I'll start off with combat, and then I'll talk about timing windows, supporting base features, and I'll end it off with a few noteworthy gameplay mechanics. The combat system is a link between code and animation. In a lot of games with combat, it's easier to keep it mainly on the code, but considering each attack has different settings and sometimes different effects, linking the attacks to the animations makes it easier to apply damage and knockbacks. I use a mix of animation events, scriptable objects, and scripting. Starting off, for each attack, I apply animation events at different points to allow for proper and consistent attacking experience. The events go as follows. First, deactivate regular controls in order to not interrupt the currently playing animation. Second, enable in attack lag action map that keeps track of any inputs made during moments of lag or lack of main control. Third, enable a collider in the weapon of the player that acts as a hitbox and disable it a bit after. And fourth, and around the end of the animation, disable the in attack lag action map and enable the regular movement map. Something to note before I continue is that I sometimes don't disable all movement actions when attacking because sometimes input is needed. For example, the aerial attacks don't disable the move action, so we're still able to move the character in the air during the attack. Also, I sometimes add other functions such as this one, like impulsing the player forward or things like that, in order to add a bit of effects to the actual attack. Moving forward after knowing the setup, in the weapon of the player, I have a script that contains a list of scriptable objects that serve as the attacks. Each attack is named after an attack animation and contains all info that the attack will have. Things like damage, knockback, hit stop, animation speed, damage scaling, and things like that. In the same script, whenever something touches the sword during the time the hitbox slash collider is active, I get the name of the current animation, and with this name, I grab the appropriate attack by comparing names with the list of attacks. Once I have the right attack object, I then move on to the damage and knockback by calling a method in a script on each hittable enemy, passing along the attack object. In each hittable, I contain a script called damage and knockback that is in charge of the damage and knockback received. It has variables to adjust such as weight that help calculate knockback. It has a coroutine that calculates the damage and knockback when called, which happens whenever attacked. First, it applies damage, then it checks the type of attack. If it's static, then enemy is just moved a bit, and if it's sent flying, then based on the attack and the enemy info, knockback is calculated. The formula for now is total damage times the attack's knockback scaling all over the way, and all of that encapsulated plus the knockback of the attack. I'll adjust the formula more as the project progresses. After that, I apply hit stop. The way I do it is I yield return to a hit stop coroutine. The way it's applied is by recording the current velocity and the current animation speed of the attacker and the attacked, then freezing the velocity and attack animation for a small period of time. Afterwards, reapplying velocity and animation speed to both. Once the hit stop coroutine is over, we simply apply the knockback that we calculated before to the rigid body's velocity of the enemy. And we just lerp it towards zero, both the x and the y axis. And if either of them reaches zero, then we stop the knockback. And that's kind of how the knockback happens. The same goes for the player. The only difference is that after the knockback, we put the player in a tumble state. A separate aspect of combat is attack canceling. In each attack, there is a list of attacks it can cancel into. It also has variables that are used as the info in order to cancel into it. For example, forward tilt, in order to use it, it must be grounded, the X input must be above a certain threshold, and the Y input must be close to zero. This info would be on the F-tail object, but the attacks that would cancel into it must add the F-tail object to their list of attacks they want to cancel into. Keeping this in mind, after an attack lands, the in attack lag action map keeps track of the inputs during the attack lag. If the attack button in this action map is pressed after an attack that contains attacks it can cancel into lands, then the list of the attacks it can cancel into is checked. So basically, if you land a hit and that attack has attacks it can cancel into, then we start checking, right? If any attack in the list contains the same cancel into variables as the current status of the player, then we cancel into that attack by playing its animation. Moving forward are the window-based inputs. In the project, I had multiple mechanics that worked in a window-based reaction, mainly being that if an input is made in response to something or as a result of something, then a certain reaction or effect would be made. These mechanics were buffer inputs, tech dodges, and smash tags and coyote time. I'll briefly go over them because again, the logic is similar in all of these. For the buffer inputs, during lag, record any input made, and once the regular movement map is turned on, meaning the end lag is over, check the current time minus the time the input was made. If the value is small enough, meaning it falls within a buffer window, then allow for the occurrence of the action said input would make. For example, if the player pressed jump in the air and hit the ground shortly after, reaching the buffer window, then once the ground check would be completed, the movement would confirm that jump was buffered and it would trigger another jump. As for text, it's very similar to jump buffer inputs. When the player is in tumble, if the player is in tumble, meaning that he it was hit but knockback is over, then keep track of when the player pressed the tech dodge button. If the player pressed it within a small enough time frame, then check input to see which tech it should be made. Otherwise, we're just gonna splat the character. Moving on to dodges, when the player presses the dodge button, we run a coroutine that lasts X amount of time. If the player did a directional input, then we break out of the coroutine and make a directional dodge. If the coroutine runs fully without the directional input, then then we just choose a regular spot dodge. Full and short hops are determined similarly based on how long the jump button is held. Now moving on to the smash attacks, it's similar. It's somewhat similar. When the move or attack input has started, we record the time. We then check when the other of the two was started and the commitment of the move input. So how far the control stick is from the center. If the period of time of each's timing is really close to the other, then that means the player wants to do a smash attack. Next is coyote time. When the player leaves the ground through movement and not by being hit or jumping, then we'll start a countdown timer. If the player jumps within this timer, then allow them to keep their last jump. Otherwise, if the countdown reaches zero, then we take away a jump. Now that the main features were covered, I want to finish off with a few extra features I put in. First up is the pass through platforms. The concept here is pretty simple. When the player is below a platform, the collision detection for it and the player is off. And when the player is above the platform in terms of the y axis, the collision is on. This basic concept came from a Chalicade short, so quick shout out to him. And lastly, is animation speed curves. For each attack object, there is an animation speed curve plus a speed scale. We use these in order to change the speed throughout the animation of the attack. The reason for that is because each attack is going to have different variations of it, and this type of method makes it very easy to adjust the speed of the attack based on the wanted effect. For example, a weak attack might be fast, and a strong attack might have a slow wind up but a quick execution. That about covers the main features of the prototype. Unfortunately, I'm unable to share the repo right now because it's a project that is still in the works. Also, we want to keep it private until we launch it, and while currently there isn't a demo build yet, I'll make sure to make one once the project has a bit more art in it. Please stay tuned for that. With that being said, thank you very much for watching my devlog. If you liked it, then definitely check out my other projects. Thank you.